Okay, so today we're going to get into something sort of exciting, sort of the big second half of the class. And so we're going to start looking at antiderivatives. And more specifically, we're going to look at something called general antiderivatives. And so we'll talk about why I'm putting the word general on there in a second. Another name which is essentially equivalent to this is it's called indefinite integrals. And so we've talked about the word integral. It's been quite a while now, but we talked about definite integrals right at the start of the class. Where we're finding area under curves. And so we're not doing that right now. We're just working backwards from the derivative. But as we'll see soon enough, there's a big connection here. And so because of that big connection, we're going to use the integral notation when we want to find the antiderivative. So for those of you who haven't seen this before, you'll notice that we have the integral symbol like we did before, but no bounds, right? And then there's this dx over here, which we haven't talked about a ton, and you don't really need to worry about it too much right now. Basically, these two things sort of go together. They're sort of like the bookends. In between there is telling me what I'm taking the antiderivative of. And so the dx is just sort of a place, a bookend, and it's telling me what the variable is, right? The variable is x. So I'm looking for a function that has a derivative of x squared. And so a lot of times just guessing and checking and knowing your derivative rules will help. And so of course if I have a derivative of x squared, I know I need an x to the third. And so then I know the 3 would come down and I don't want the 3, so I put a 1/3 in front. So I put that 1/3 in front. So that is an antiderivative. The catch is there are lots of antiderivatives, right? Because if I put a +1 or a -100 or a plus pi at the end, those would all still be perfectly legitimate antiderivatives because the plus number would go away. And so I'm just going to put a plus c here. And this is super, super important. It will come up a lot. When you're doing the general antiderivative or the indefinite integral, it's a family of functions, right? This plus c, the c is any number. It can't have an x in it, but it's any number. It will just go away when I take the derivative. And so, like I said, a lot of these problems you can just do with guessing and checking. You can also make use of a couple properties. And so once you get the hang of it, you sort of don't need to write this. But if you have a constant in front of your function, you can just pull that constant out in front. So just sort of ignore the 5. It's part of the answer, but I don't need to do much with it. It just sits there. What's the antiderivative of x squared? Well, same thing it was before, right? It's 1/3 x cubed. And then I put my plus c at the end. And you can leave it like this. If you want to clean it up, you could say, oh, that's 5/3 x to the third plus c, right? Never hurts to take your derivative just to check your work, right? Take the derivative, the 3 comes down, turns that into a 5, the new power is x squared, the plus c goes away. I'm good to go. Sometimes you'll also see things being added up inside an integral. And again, once you get the hang of this, you don't need to write this out this explicitly, but the rules of integrals do allow you to break this into 2 separate integrals. And so what has a derivative of sine? And so you have to be careful here. What has a derivative of sine is negative cosine, right? So that negative's important. What has a derivative of 2x to the third? So I would add the power, right, and get 4. And then I divide by 4, so 2/4 is 1/2. And so I put the plus c there. And again, take the derivative, make sure you're getting the right thing back. And I think we will in this case. Last one, what has a derivative of 1/x? Hopefully that jumps into your head. It's ln of x. The one catch is ln of x you can't plug negatives into, or 0. This you can't plug 0 into, but negatives work just fine here. And so we're not going to get into the details of this, but whenever you take the antiderivative of 1/x, you always want to put those absolute value bars around the x. That makes sure that the domains of the 2 functions match up. And we'll just put plus c here, right? And so if you look at the memorization list, and so let's see if I can pull that up here. If you look at the memorization list, you will see that there are a bunch of derivative rules on here. Why can't I find it? Here we go. There are a bunch of antiderivative rules on here, and they're basically just backwards from the derivative rules. And so if we scroll down here, got all our derivative rules. and then got some properties of integrals that we'll talk about eventually. But down here we have the antiderivatives, right? And I've just got a couple listed, and then it says plus the reverse of all the derivative rules, right? And so basically, as long as you know your derivative rules, you'll pretty much know your antiderivative rules. I've got a couple sort of ones highlighted here. The antiderivative of e to the x, of course, will be e to the x plus c. So this is the end of this first video. So now you're going to work on some problems in groups. And before you get started, I would recommend just checking in, especially with those people who haven't seen this before. Was this making sense? Do you have any questions? And then you're going to work on a few problems in groups that are a little bit more complicated. You're working backwards from the chain rule. And don't be afraid to try, guess, and check.